This video is for lesson 4.1, and the learning target for this lesson is I can classify triangles and find angle measures. Please make sure you're using a pencil when you're writing your notes, and please make sure you have the audio on because I will be saying some things in the video that are important, and just by pausing the video and writing down the words, that's not going to get you all of the information that you need. So please make sure that you're also listening to the video at the same time as you are writing down the information. There's some vocabulary terms right at the very top that are important to write down, and you will be required to remember what kinds of triangles we're dealing with. So you may be asked to write, what the name of a triangle is or what type of triangle we're dealing with. So let's make sure that we know that obviously a triangle is a polygon with three sides. So the first three letters, TRI, indicate that there are three. Tri. So scalene triangles have no congruent sides, so 0 sides congruent for a scalene. Equilateral triangles have 3 congruent sides. So you may see a picture of a triangle with 3 tick marks, 1 tick mark for each side, and that indicates that it's an equilateral triangle. An acute triangle has 3 acute angles, and we know that acute means less than 90. A right triangle has 1 right angle, so a right triangle would look something like this with that little indication that it is a right triangle, the 90-degree mark. Okay, and then over on the right-hand side, we have the obtuse triangle. There is one obtuse angle in an obtuse triangle, and those are the ones that are really quite flat. Okay, the triangles look kind of flat because this angle here is more than 90 degrees. And then we have our equiangular triangle, which has 3 congruent angles. Okay, another picture, but it would have 3 arcs, showing that the angles are all congruent. And then we have an isosceles triangle that has at least 2 congruent sides. So those are kind of tall and skinny generally. The 2 sides would just be, they are called legs. We're going to have a whole lesson on just isosceles and regular triangles, so we'll get to that later. But for now, just remember that isosceles triangles are those that have 2 congruent sides. All right, and then we have this information here. When the sides of a polygon are extended, other angles are formed. The original angles are the interior angles, and the angles that form linear pairs with interior angles are exterior angles. So let me just give you an example because we're going to have one of these in just a moment. So we have a triangle here, and we have some angles. This angle, and this angle right here. But if I extend the side, now we have something that we would call an exterior angle right here. It's outside of the triangle, but it is in a linear pair with the one inside here. So if I extended this side of the triangle down, then this exterior angle is now a linear pair with this angle here. So we have exterior angles, and then we have interior angles. So please make sure you know the difference between those. And then I would like to go over the triangle sum theorem, which really is quite simple. It just says that the sum of interior angles of triangles are 180 degrees. So the sum of interior angles of any triangle must add up to 180 degrees, like that. So no matter what type of triangle it is, the triangle's angles will always add up to 180. All right, so let's take a look at the next theorem, Theorem 4.2, and don't concern yourself with knowing which number theorem it is. You don't have to memorize that it's Theorem 4.2, but you do need to know what exterior angle theorem says, or what the idea of it is. It says that the measure of an exterior angle of a triangle is equal to the sum of 2 non-adjacent, and there is another word that we use for non-adjacent. Non-adjacent could also be remote, okay? We sometimes call these angles remote. Remote just means away from the area, so somewhere else besides the angle that's just inside. Okay, so the exterior angle of a triangle equals to the sum of 2 non-adjacent interior angles. And we will be doing a couple of problems for practice to see how this theorem works. And then we have one thing here, the corollary to the triangle sum theorem, and it states that the acute angles of a right triangle are complementary. And you may remember that complementary means that they are equal to 90 degrees. So the non-right angles are complementary, and that just means that they add up to 90 degrees. So we're going to practice a few problems now that kind of go through each of these theorems, and also we're going to look at different types of triangles based on the vocabulary that we saw at the top of the page. So let's go ahead and go to the examples now. Example 1 says that we want to classify the triangle by its sides and its angles. So it's important that you understand there are 3 ways to classify something, or the triangle by its sides, and there are 3 ways to classify it by its angles. All right, so each one of these we should say when we're looking at the sides and then when we're looking at the angles, we want to give it a name. All right, well in this case, it looks like all of the sides have a length of 17, and then it looks like all of the angles, each angle I mean, is 60 degrees. So if we go back up and look at the definition, all sides are congruent and all angles are congruent. It looks to me like we have 3 congruent sides, so that would be equilateral. And then we would have 3 congruent angles, which would be the equiangular type of triangle. Okay, so let's take a look at naming this one then. For all the sides being congruent and all of the angles being congruent, we say that this is going to be equilateral when the sides are all congruent. And this one is going to be equiangular. Now, when we were talking about polygons in last semester, we know that if something is equilateral and equiangular, we would call that polygon regular. So this is a regular triangle, and the reason that it's regular is because it's got all angles congruent and all sides congruent. All right, let's take a look at problem B. Problem B still is asking us to classify the triangle by its sides and by its angles. And according to the side lengths 19, 23, and 8, none of these sides are congruent. So the sides, we would call this a scalene triangle. And if we were classifying it by its angles, are any of the angles, well, it looks to me like the angles have a 19 degree, 51 degree, and 110 degree. 110 is an obtuse angle, and so since all of the angles are not less than 90, we can't call it acute, but because there is at least one obtuse angle, we could call this an obtuse triangle based on the angles. So this is called an obtuse scalene or a scalene obtuse. You can reverse the name, reverse these words if you'd like to. So either way, that's still a scalene triangle and it's still an obtuse triangle. But if the problem asks you for both, please make sure you identify both. Okay, so for problem C, we're taking a look at this diagram, and it looks like we have lengths of 4, 4, and 4 root 2. And those are all different. Actually, there's 2 of them that are the same, aren't they? So we could put tick marks on those sides, and those actually have 2 lengths that are exactly the same length. They're congruent sides. So 2 congruent sides. So if I'm writing out what kind of triangle it is based on its sides, I would have to say isosceles. And this is a funny word to spell. Sometimes it's difficult. Just remember that there's a C in the word isosceles. And then angles, if we look at the angles, what kind of angles do we have? Well, we have 2 45-degree angles, and then this one, which of course that little box there means that that one's 90. So that means we have a right triangle. So we have a right isosceles triangle, or you could call it an isosceles right. Either one, right isosceles, isosceles right, we both, both terms are correct. All right, so I would like you to finish D, E, and F, and all you need to do is make sure that you remember to include a name or a type of side. Name the triangle by its sides as well as its angles, and you want to do that for each of those 3 problems at the bottom of the page. And on the back of our note sheet, we have a couple of example problems that I would like to go over with you. You'll notice that problem A and problem B are the problems I'm going to do with you, and then down toward the bottom of the page you have a couple of on your own practice problems. So it's important that you listen to the video. Don't just write down what you see on the screen, but also make sure that the video is playing and you can hear the audio, please. So we are going to find some angle measures. We need to find the measure of angle BAC. BAC is this angle right here. So we have to find this measure, and then we also have to find BCA. So we're also going to be finding the measure of this one here. So if we take a look, this measure is 90. Now, one of the theorems that we wrote out on the front side of the page says that the measure of the acute angles in a right triangle are 90. Okay, so this one right here is acute. We know that. And this one right here is acute, because if you think about it, there can only be one angle in a triangle that is 90 degrees. The other 2 angles are complementary. So the 2 acute angles equal 90. So now I can set up my problem because I know that this angle and this angle have to add up to 90. So let's go ahead and write it out. 4x minus 5, this angle here, plus the other angle, 3x plus 11. They have to equal 90 degrees because in a triangle, all 3 angles must equal 180. So if this one is 90, the other 2 angles have to add up to 90 as well. So I can go ahead and work my algebra magic. 4x and 3x can be combined. They're on the same side of the equal sign, so 7x. And then I can also combine the negative 5 and the positive 11, which ends up being positive 6. All right, and now I can subtract the 6 from the left and also the right. That cancels. I have a 7x equals 84. And if I divide by 7, I end up seeing that x is going to be 12. All right, and so because x is 12, I need to plug that back in to my original expression for this angle right here as well as for this angle right here. So if I plug in 12 for 3x plus 11, I am going to have 3 times 12 plus 11, and that's for angle BAC. And for BCA, I'm going to have 4 times 12 minus 5. So when I work that out with my calculator, I get 47 degrees for BAC, so this one's going to be 47. And then I would see that 48 minus 5 is going to be 43. Now, one thing that you would want to check is to make sure that these 2 angles, once you get your answers, actually do equal 90. If they don't equal 90, then of course we have done something wrong and maybe your value of x was incorrect. But because we see that they do add up to 90, we know that x equals 12 is correct. If you have any questions about that problem, please make sure you ask in class, and I would be happy to help you with that. And then for part B here, it says find the measure of angle BCD. So BCD is this angle right here, and notice that it is an exterior angle. Okay, so exterior angles, we have a special theorem for that. This angle here has to equal the sum of these 2 angles. These angles over here we would call the remote angles or the non-adjacent angles. Okay, so you probably already know that an adjacent angle would be the one right next to the interior angle. So we would call this one adjacent. And then the other 2 angles, this 2x here and the 76 here, are going to be the ones that we call remote or non-adjacent. All right, so our theorem says that the exterior angle has to equal the other 2 angles in the triangle. Not this one. We can't count this one. but we would have to add up 2x plus 76. That's going to have to equal the exterior angle. All right, so let's go ahead and do this. So 5x, which is our exterior angle, minus 2 exterior, has to equal the other two remote angles. So 2x is a remote angle, and 76 is also. So I'm going to work my algebra magic. I'm going to add 2 here, add 2 over here. And so on the left side we have 5x, and on the right side we have 2x plus 78. And then if I subtract 2x here, I'd have to do that on the left as well. And so now I have 3x equals 78. And then I'm going to divide by 3 on both sides. And so I'm going to find out what x is. And x is going to be 26. 78 divided by 3 is 26. And now I just have to plug this back in because my ultimate question was, what is the measure of angle BCD and what is the measure of angle ABC? So I need to plug back in x equals 26 to this, and I also need to plug it in to this expression. So 2 times x is just going to be 52. And then when I plug x in for 5x minus 2, my 5 times 26 minus 2, that ends up being 128 degrees. And if I look at the measure of the outside angle, the exterior angle, which is 128 degrees, we just said that, then how much is the measure of these two together? Well, this one is 52, and we already knew that this one was 76. So if we add those together, that also equals 128, and therefore you know your answer for x was correct. Alright, so you're going to finish up the backside of your note sheet by finishing these two problems. So once again, think about those theorems that we were looking at in the practice problems that we just did. Remember, you need to solve for x, and then you also need to plug the value of x in to find the measure of each of these two angles. And that's going to be true for both problems 1 and 2, right? So you're going to solve for x. So set up the problem, kind of like the ones that I just did for you. And then once you find out what x is, plug it back in to find the measure of those. And you will get a stamp on your notes if you finish all of the notes. So make sure that these get finished so that you do get that stamp. Thank you so much for watching.